Hello everyone. My name is Huda Ali. I am the manager of the nomenclature and classification of rare diseases at Orphanet, and I coordinate the collaboration with ERNs on the update of the nomenclature. I am here to give you an introduction to the Orphanet nomenclature, explain to you how it is updated, and show you how to find and use the ORPHAcodes using the different tools that we provide through our platforms. I also have included a chapter on why a nomenclature is specific to rare diseases is needed, but since there is a lot to say and I don't want to overload the presentation, if you wish, we can discuss this aspect during the Q&A. Otherwise, in any case, it will be present in the PowerPoint for your information. So let's start with the Orphanet nomenclature, and I will introduce this part with this graphic representation of the Orphanet database. As you can see, the rare diseases themselves, which collectively form the Orphanet nomenclature, represent the essential core of the Orphanet database, around which many scientific data and resources are structured. These include genes, alignments with international terminologies, epidemiological data, clinical science using the human phenotype ontology, and in addition, Orphanet maintains an encyclopedia for health professionals with the summarized text that you can see on the disease page on the website, which are all validated by experts. And notably, Orphanet provides a catalog of expert resources dedicated to rare diseases, which include orphan drugs, patient-centered services, as well as research activities. And these expert resources are collected in member countries of the Orphanet network. Concretely, the nomenclature of a rare disease is composed by the following elements. First, an ORPHAcode, which is a numerical identifier attributed to the entity by the database upon its creation. A preferred term, which is the most widely accepted term for the entity in the medical community. Synonyms, which are other used terms that are perfectly equivalent to the preferred term. And a definition, which is a short textual description of the main clinical characteristics of the entity, which therefore completes the information provided by the nomenclature terms and enables to avoid any ambiguity on the diagnostic scope of the disease. The nomenclature is produced in English by default by the Orphanet coordinating team, which I am part of, based in Paris, and is translated into several other languages. Currently, the nomenclature includes a little over 6,000 entities at the disorder level. We will see right now what this means. But first, I'm just showing you how the disease page can be viewed on the Orphanet website. You can find all the components that I just mentioned, the ORPHAcode, the main name, the synonyms, and the definition. In addition to these elements, each entity is attributed what we call a classification level, reflecting the level of precision of the diagnosis. There are three possible classification levels, which are the groups, the disorders, and the subtypes. A disorder is defined as a clinically homogeneous entity, and it reflects the level of the confirmed diagnosis. European recommendations indicated it as the reference level for data sharing and statistical analysis of rare diseases across Europe. Subtypes are only created when this level of precision of the diagnosis is pertinent and useful in clinical practice. So here is an example. We're going to use this example throughout the presentation. It's a renal disease. In the nomenclature, atypical hemolytic uremic syndrome, or atypical HUS, is present at the disorder level, and within the classification of rare renal diseases, it is included in the HUS group, which is itself included in a group with a larger scope, which is the thrombotic microangiopathies. This disorder has two etiological subtypes, because even though both have a similar clinical presentation, The Orphanet experts have advised that this level of precision in the diagnosis is necessary for appropriate patient management according to the identified etiology. So it is important to keep in mind that each entity has one unique ORPHAcode and is attributed one classification level. The Orphanet nomenclature is not present as a simple list of rare diseases in the database. It is actually organized in a classification system, a relational structure that uses the entity's classification levels and parent-children relationships. Classification system is organized in 35 main classification groups, also called heads of classification or hierarchies, each corresponding to a medical specialty or biological system. Therefore, this system is multi-hierarchical, but it is also a polyparental system, since a given disorder is classified in as many hierarchies as necessary in accordance with its clinical characteristics and the medical specialties that it relates to, and can have different parent groups throughout the different hierarchies. For example, atypical HUS is a hematologic condition with a significant renal manifestation. Therefore, it is present in the renal diseases classification, in the HUS group as we saw earlier, but it is also included in the hematologic diseases in the group of rare constitutional hemolytic anemias. In this case, we say that the entity is multi-classified. About 70% of entities present in the nomenclature are multi-classified, which poses a problem for statistical analysis, since if you do a counting of diseases using several classification groups, you will count many entities more than once. As a solution for this, we perform what we call a linearization process, which attributes one preferential parent to each entity among all the hierarchies that it is included in, which is usually the most significant in relation to the medical specialties involved in the diagnosis and management of the patient, or the biological system that is the most affected. In the case of atypical HUS, the preferential parent is the renal disease group. This linearization process is based on a defined set of rules listed in a procedure that is accessible on the Orphanet website. However, I wanted to point out that Orphanet should not be viewed as a scientific authority in view of this linearization process. The rules that we have established are subjective and simply aim to ensure a homogeneous methodology of attribution across all entities. In addition to the possible multi-classification across different hierarchies, an entity can also be multi-classified within the same hierarchy. Here is the example of Fanconi-Bickel syndrome, which within the classification of rare metabolic diseases is present in two different groups that you can see here on this slide. A quick word on the political context surrounding the Orphanet nomenclature. Currently, it is officially adopted for the coding of rare disease patients in health information systems in 3 countries, France, Germany, and the Italian Veneto region. And there have been recommendations published by the European Commission that mention the use of ORPHAcodes for the coding of patients. And there is an ongoing project that you may have already heard of, the RDCode project, which is funded by the European Commission as part of its 3rd health program to promote and help the implementation of ORPHAcodes into more member states. And 4 countries are directly involved in this project, which are the Czech Republic, Malta, Romania, and Spain. Now let's see how the nomenclature is updated and the different criteria that we use. There are 3 main types of action that can be done in the nomenclature. The first one is the creation of a new clinical entity. If we focus on the disorder level, the entity must represent a clinically homogeneous phenotype. It must fit the prevalence threshold of less than 5 in 10,000 individuals in the European population, as per the European definition. And we also have an additional criteria in Orphanet, which is that the phenotype must be described in at least 2 published cases in the literature in order to make sure that it is not a fortuitous association of clinical signs. The second type of action is the modification of an existing clinical entity. This can be an update of the preferred term or synonyms, or a modification of the classification level. This is quite rare, but it does happen sometimes. We can take an entity out of classification group and move it to a different group. And some phenotypes can be labeled as historic. And this is when they have been described, a phenotype has been described before the advent of the genetic era, but no new cases or information have been reported since then. But they are still considered as distinct phenotypes and are cited by reviews or in the differential diagnosis of newly described disorders. And a reassessment of the phenotype is possible, so we therefore keep them in the nomenclature. But we simply mention in the definition that the phenotype, there have been no further descriptions in the literature since, let's say, 1987. The third type of action, and this is an important one, is the inactivation of an existing entity. This can happen in 3 contexts. First, the first one is the inactivation by obsolescence, which occurs for 4 reasons. The phenotype does not represent a real entity and cannot be clearly or independently defined, or it is an exact duplicate of another active ORPHAcode. We try to be careful, but this type of mistake has already happened in the past. Or the phenotype is only described in 1 case, which is possible because the 2 published cases rule has not always existed. And finally, it can be the removal of an organizational category or an entity that does not reflect the clinical practice. And I'm going to show you an example of what this means. If we go back to our example, atypical HUS, this disorder used to have several etiological subtypes, each associated with a gene of the complement system. However, during the collaboration with Orphanet, the experts indicated that these subtypes were not useful and should be obsoleted, and that creating one simply named atypical HUS with complement gene abnormality would be a lot more pertinent and more useful. So this is what we did. A relationship was technically established between the obsoleted subtypes and the newly created ones, that must be used instead. We say that the obsolete entity is referred to the active one. The second context of inactivation is the deprecation. This happens when a phenotype that was initially described as an independent diagnosis, when it was first described, has been included in another phenotype following an evolution of knowledge. Here is an example. We used to have an entity called LAMP2-related infantile onset nephrotic syndrome, which resembled Pearson syndrome, but was considered as distinct due to the ocular anomalies being less significant than in Pearson syndrome. However, the diagnostic scope of Pearson syndrome has evolved, and now only the renal involvement is considered as constant, whereas the ocular and neuromuscular changes are variable. Therefore, all patients with nephrotic syndrome and LAMP2 mutations are now diagnosed as Pearson syndrome. So we have inactivated the LAMP2 entity and established a move-to relationship with the now recognized entity, the active one, which is Pearson syndrome. This information is visible on the Orphanet website for deprecated entities and stated in an automatic text for the appropriate redirection of the user towards the active ORPHAcode that they must use instead. The last case of inactivation is for entities considered as non-rare in Europe. This one is quite straightforward. An epidemiological assessment of the phenotype has led to the conclusion that it doesn't meet the European prevalence threshold of less than 1 in 2,000 individuals in the European population. Therefore, it is removed from the nomenclature and the ORPHAcodes must no longer be used. This table summarizes the types of relationships between inactivated ORPHAcodes and the active ORPHAcodes that must be used instead. In the case of obsolete entities, the target ORPHAcode that we enter in the database must be viewed as a suggestion, in contrast to the target code entered for a deprecated entity, which must be used as a replacement because it effectively follows the evolution of knowledge. As for non-rare diseases, we do not enter matching ORPHAcodes because the phenotype is out of the rare disease scope, so the Orphanet nomenclature does no longer apply to these patients, and we usually recommend to use the ICD-10 code instead. A quick word on Orphanet and the collaboration with ERNs. Collaborative effort has been ongoing between Orphanet and the ERNs since their establishment in 2017 for the update of the Orphanet nomenclature and other information, and mainly because the ORPHAcodes are used in ERN patient registries. Generally speaking, the role of the ERNs is to review the scientific accuracy of the information, share with us their experience as clinical, experts, and if they see inconsistency, help us identify what needs to be done with the information. On the other hand, we at Orphanet provide databasing expertise by transposing the currently available knowledge into a structured, consistent, and standardized system. We aim to facilitate the collection of new data on rare diseases in Europe, and we help ERNs organize their data. Here's a state of play of the current collaborations and the ones that are already finalized or under finalization. And now I'm going to show you where you can find nomenclature information and more specifically the ORPHAcodes. All the information that is present in the Orphanet knowledge base is freely accessible through 3 main tools: the Orphanet website, the ORPHAdata platform, and the Orphanet rare disease ontology. Let's start with the Orphanet website, which is the most well-known. Actually, I'm going to do a live demonstration, so I'm just going to switch to my other screen. Just one moment. Here we go. Okay, can you see my Google Chrome screen?
Yes. Yeah.
Okay, so here's the Orphanet website. The website provides information by disease or by groups of diseases in the different languages of translation of the databases. It is mainly aimed at health professionals, but it is of course also consulted by patients and their families, among other users. So you can use the search engine to search for any disease you are interested in. So if we type atypical HUS in the search engine, you will have a list of results, and each result you will find the synonyms and the classification level, which will help you choose which one you want to display. And you can, so this is the disease page where you can find all type of resources, and this is the identity card where you have the alignments with international terminology, age of onset, natural history, etc. And so this one only has a definition for now, but an abstract, a more detailed abstract might possibly be published in the future. And you can also do this search using the gene section here on the left. For example, if I search the CD46 gene, it will show me a list of results. And if I click here, I will have the gene page with a lot of information related to the gene itself. And then I have a list of the diseases present in Orphanet that are linked to the gene. And then you have one of the subtypes of atypical HUS, which is specifically linked to CD46. And then you can access the page through this link. And this search can be also done using, the MIM number, be it the OMIM, the gene OMIM or the phenotype OMIM. But if you look through the main search engine, only the phenotype OMIM will work. It is not specified here, but just keep it in mind. And finally, you can also search using the classification section here. And again, if I tap the atypical HUS and I want to specifically see how atypical HUS is classified, it will display all the main hierarchies that it is classified in. So I want to see the classification of renal diseases. And here is the view of how it is classified. And this is the same, information that I showed you on an earlier slide, the successive groups it is present in and the two subtypes. Be careful that the result displays how the specific entity you search for is classified within one given specialty. In other words, the successive parents and the children the entity has. It will not show you the other entities present at the same level, because of course, there are other entities present in HUS. But if I want to know what these other entities are, I need to repeat these steps, but this time focusing on HUS. And then I'll have, the display of the disorder classified in the group. The Orphanet website is synchronized daily with the Orphanet database, which means that if I create a new entity right now, in this moment, it will be visible on the website tomorrow, because it usually takes about 24 hours to be synchronized. Also on the Orphanet website, we have another tool that can be used to search ORPHAcodes. It is present in the Orphanet report series section, where you will find a list of all rare diseases with their synonyms by alphabetical order, and it is available in different languages and published annually. It also includes the list of deprecated entities with the redirection to the matching active ORPHAcodes. Up until now, this list was published in a PDF format, but it will be replaced by an Excel format, and the new version is scheduled to be published in the coming days, actually. Just be careful that this file only includes the preferred terms and synonyms of rare diseases with their classification level, but it does not include the definitions. Now moving on to the ORPHAdata platform. So it is a different site. And by the way, don't worry, I linked all the tools in the PowerPoint presentation, so you will find everything in there. So on the Orphanet, the ORPHAdata website, we provide aggregated data in computable and reusable datasets obtained by extraction of the Orphanet database. These constitute a useful tool for researchers or any person who needs to perform massive analysis of rare diseases and associated data. So you will find and can freely download different data sets, including those related to gene diseases relationships, epidemiological data, phenotypical annotations using the HPO terminology, and functional consequences. As for the data that is directly related to the nomenclature, you can access these in the Rare Disease and Classification section, where you will find a data set for the alignment of the nomenclature with external terminology, such as OMIM, ICD-10, GARD, UMLS, etc. You also have data sets for the classification, so there is one for each head of classification, and the linearization of disorders. These data sets are available in different languages, and they are synchronized with the Orphanet database on a monthly basis, and are all provided in an XML format, which can be opened using an XML reader, and you can use parser scripts for data exploitation. I'm not going to get too technical in this presentation. There should be another one later on the more technical aspects of how to use the resources provided by Orphanet. In the framework of the ORPHAcodes project, we have developed the nomenclature files for coding, which we also call the nomenclature pack, which are used for the implementation of the ORPHAcodes in health information systems. This pack includes the main Orphanet nomenclature file, where you will find all the active ORPHAcodes with their preferred terms, synonyms, and definitions. And you will also find the inactive ORPHAcodes, each listed with the active ORPHAcode that must be used instead. The pack also includes an ICD-10 mapping file, as well as a directory containing the Orphanet classification files. All of these files are also provided in an XML format, and the nomenclature pack is published annually in July. This is indicated here. The last one was published in July 2020. Based on this nomenclature pack, we have also developed an application programming interface, an API, which enables to design customized queries for specific use case, integrating raw Orphanet data. Again, I have linked these in the PowerPoint, so this leads you to this page, and you have to click authorize and enter, any value. Doesn't matter. And then you can search for raw Orphanet data using different criteria. For example, I want to do a search by preferred term. Then I will go here, click on try it out, and type the disease name that I'm interested in. And then it will display the results, in this format. And, this can be used for tooling and, to create new tools integrating the Orphanet data. And in fact, we have very recently launched a data visualization tool built on this API, which I'm going to show you here. I quite like this one because you can really search using, the clinical entities and display associated data. And more importantly, you can browse the classification system. So if I type, still the same entity here, I'm going to let's be a little bit specific here. If I click on atypical HUS specifically, and I'll go to the visualization screen, I will be able to see the children of the entity. Actually have a small legend here with the colors. So we find the same subtypes that we saw earlier, and we saw all the parents in which the entity is classified in Orphanet classification system. So this tool is still under development, so this is not the definitive version. It's going probably to evolve, soon, to integrate maybe more features and optimize the way you can visualize the arborescence. Finally, I'm going to show you the Orphanet rare disease ontology, which we call ORDO. It's a structured vocabulary derived from the Orphanet database that is aimed at bioinformaticians for the computational analysis of rare diseases. It integrates the classification system, relationships with genes, epidemiological data, mapping to international terminologies, and it is synchronized twice a year with the database. I will not go into more detail regarding ORDO, but as a small tip for those who are interested, you can visualize ORDO through the ontology lookup service available on the European Biomedical Institute website, which I linked also in the PowerPoint. So if I go to the website and I can ask to look at the ORDO, yes. Here. So I access ORDO here, and then I can type the name of the disease. and I will be able to see all this information. You have the classification here, the international alignments, the terminologies. And usually if there is a definition, it will be displayed at the top of the page. It is here. And you have various information such as natural history, etc. And it even says what children are included under this entity. And if the entity is inactive, it will also indicate the matching codes, the active ones. Going back to my PowerPoint presentation. And where is it? It is here. Here we go. So I'm going to skip. We have already seen all of this. Okay. All right. Here is a summary of the nomenclature dissemination tools provided by Orphanet. It is very important to keep in mind that these tools are synchronized with the database at different frequencies. For example, the nomenclature pack that is currently accessible online does not show the creation and updates that have been done in the database since last July. So as a general recommendation, if you use any of these tools for patient coding and feel that an ORPHAcode is missing, do a quick check on the Orphanet website, which is synchronized daily, in case the entity you are looking for has been created recently. Of course, if you still cannot find it, you can contact us. You can find all matching ORPHAcodes available for inactive entities in the nomenclature pack and Ordo. And the Orphanet website and the Orphanet report series list only include the matching code for deprecated entities. A few things to keep in mind when searching for and selecting ORPHAcodes. The first one is that one ORPHAcode equals one positive diagnosis. For example, we have a disorder for infection-related hemolytic uremic syndrome, HUS, with two subtypes defined by the two known infectious agents and cause. In case you need to code a patient in whom the diagnosis of HUS is confirmed, there are known elements indicating that it was caused by an infection, but the precise agent involved is not known, either because the clinical assessment is incomplete or because the known agents were excluded, then you need to use the ORPHAcode at the upper level, which is, in this case, infection-related HUS, because this is the level of information that is available for the diagnosis. The same can apply for disorders versus groups. You have a patient in whom the clinical manifestations of HUS were observed, but the known information do not allow to determine what type of HUS it is yet. So you must use the code at the group level in this case, which will mean that the patient is awaiting a definitive diagnosis. And then the ORPHAcode can switch to the exact diagnosis at the disorder level. And finally, we have the case of a clinical manifestation that is part of a main diagnosis. For example, in the context of the Orphanet registry, you need to code a patient described as having a thrombotic microangiopathy, TMA, associated with systemic lupus erythematosus. In this case, the TMA itself does not represent the main clinical diagnosis of the patient. It is actually a partial diagnosis that is from the viewpoint of one specific medical specialty, nephrologist. And the main diagnosis is SLE, and therefore, the code that must be used to code the patient is SLE. It is possible for a given ERN to identify particular needs in view of the patient's coding, needs that are specific to the medical specialty that is covered. Here is an example from a very recent discussion with representatives of the ERN Eurogen. They explained that for patients affected by an anorectal anomaly as part of a multisystemic syndrome, it is necessary for them to specify the type of malformation that is in cause so they can determine the appropriate surgical management of the patient and also perform statistical analysis and so on. And they wanted to reflect that in the ORPHAcodes. However, we explained that only one ORPHAcode is usually attributed to the patient, which reflects the main diagnosis, such as, for example, Down syndrome. Therefore, one solution could be for the Eurogen registry to include an additional area in their information system where a more precise description of the type of ARM involved can be entered, possibly using the ORPHAcodes that we have for isolated ARMs, or it could be another terminology, such as, for example, the HBO annotations. So the main idea here is that the ORPHAcodes describe diagnoses, not patients. We provide the service, but this kind of specific issues must be addressed within the ERN in order to adapt the coding tools or the coding policy. If you notice that an entity, an ORPHAcode, is missing in the nomenclature, or that an existing entity is present but shouldn't be, you can contact us through the Orphanet website, either through the Contact Us button. Okay, I put them in the wrong order. The Contact Us button that is at the top of the page, or through the Suggest an Update button that is present on the disease page. And you will be asked to fill a form, and this form will reach the disease team. And otherwise, you can also contact us directly by email on this address.